In this video, we're going to be setting up a simple application that's designed to pass a custom data object between an iOS app and a watchOS app. All I've done so far is set up the basic project that's given to us when we create a new watchOS project. The first thing that we're going to want to do is create our custom data class that we're going to pass back and forth between these two systems. So let's go ahead and add a new file in order to do that. This will just be a Swift file that we're adding. And I'm going to call this balance. Now, you can see at the bottom here, there are several targets that we can choose from as far as what we're going to use this class for. Now, obviously, the basic iOS project, we want this to be a part of that so that we can set up our data. But we also want this class to be a part of our watch kit so that we can use the same class in both places without having to copy code or do anything like that. Now here I'm going to set this to add to the WatchKit extension target. Now the WatchKit app target is typically where we're going to just do things like interface creation, storyboards, and any additional assets that are needed for those systems. The extension is where we're going to do all of our coding for the watchOS. So that's where I want this balance class. And let's go ahead and add it. Now this balance class isn't going to be anything special. All we're going to use this for is storing a couple of different strings that I want to send from my iOS side to my watch side. So this is just going to be an NS object, but this also needs to conform to NS coding. Now the reason for that is NS coding is going to allow us to take this custom class and package it up as data so that we can send it across to our watch. So in here, I'm going to add a couple of variables, one for the date, and we're just going to use that as a string, and another for a balance string. Now I'm also going to go ahead and add an initializer so that we can have one that's based around our two variables here. So we'll have one that takes in a date string as well as a balance string. And in here, we're not going to do anything special. We're just going to assign what gets passed in to our internal variables here. So self-date equals date, and self-balance equals balance. Now after that, we need to go ahead and set up our encode and our decode for the NS coding system. So first up, we'll go ahead and set up our decode. And this is going to be a required convenience initializer. And you can see right here, this is actually what we want. We want this coder, a decoder, NS coder version. Now with this, we'll need to first make sure that we actually have something just in case we run into an issue actually decoding the object. And that's where we're going to use the initializer we just made. So in there, we'll go ahead and set some dummy value for the date. It doesn't really matter what we choose here. And we'll also set something for the balance. So we'll just put 1,000 there. And this is actually a good place to go ahead and put data that doesn't really make a lot of sense, maybe a date that couldn't possibly exist or something, so that should that information actually display, you know that something went wrong with the decoding, and it makes it a little bit easier to track down. So now I'm going to go ahead and actually decode the data. First up, we'll go ahead and set the date. So we use that NSCoder object, a decoder, and we're going to use its decode object method. Now you can see that there's a lot of different ways that we could decode this, but what we want to do is decode object for key. So just like using a dictionary, we're going to use a custom key to assign that value. And in this case, I'm just going to call mine date string. And then we're going to need to make sure that we cast this back to an actual string object. And we're going to do the same thing for balance. So we'll say balance equals a decoder, decode object for key, we'll use balance string for the actual key here. And again, make sure that we go ahead and set that as a string again. And that's all there is to it when it comes to decoding. So really all we're doing is essentially telling the system, here are the keys for what I want, and give me that data back. So in order to encode this data, we're going to need to create a function called encode, and you can see that this will autocomplete for you with acoder and scoder again. And in here, we're going to use that coder object to encode. Now, what I want to do here is pass in the object that we want to encode, so in this case, our date. And then for key, and we'll give it the same key that we used when we were decoding it up above here. And we'll do the same thing, call encode, for our balance string. And again, we'll say for key, balance string. And that's all there really is to it. So basically all we're doing here is just allowing the system to store this data out as a key value pair. And that way it understands how to actually take that data and put it back into our variables for our particular class. Now, if you had variables within this class that were other custom objects, you would also have to make sure that those are NS coding compliant so that it again understands how to package that as just data and save that out to the system, or in our case, package it as data so that we can send it from the iOS side to the watch side. So now that we have our balance class created, let's go ahead and move over to the app delegate for our iOS project. Now over here, we're going to set up one side of the connection for passing our custom object between the two systems. The first thing we need to do is we need to go ahead and import the watch connectivity module. And this is what's going to allow us to use WC sessions in order to pass our data back and forth. Now, in order to use WC sessions, we need to go ahead and create a variable for one first. So we'll create a variable called session, and this will be a WC session. Now I'm going to initialize it with a did set so that we can double check to make sure that our actual connection is available before we even bother initializing this object. So in here, we're going to say did set. And then we'll say if let session equals session. So again, we're just going to make sure that this has data. It's, something that can actually be used. We'll go ahead and set our session delegate to ourselves. And this is going to yell at you here for a little bit, but we're going to go ahead and make an extension on the delegate. And that's what's going to allow us to actually use the WC session delegate methods. And we're also going to call activate on the session. Now, activate's going to be required before you can do anything between these two objects. So, we're going to have to make sure that we're actually able to establish a connection between the phone and the watch before we do anything else. Now, the next piece I want to do is here in did finish launching with options. So before we return out of here, let's go ahead and double check that our session is actually supported. So we'll use the WC session classes is supported method, and this returns to us a Boolean. And all that Boolean is telling us is whether or not we can actually establish a session between the watch and the phone. And if we can, we'll go ahead and set our session equal to the WC session default session. Now that's all we need to do to actually establish that the session is available and assign it to our own session variable. And you can see once we do this set here from the default to our session variable, that's what's going to trigger this did set here and allow us to set the delegate as well as call activate. Now for the rest of this, I'm actually going to go ahead and clear out the remainder of these delegate methods just to make the class a little bit cleaner and easier to read as far as what we need for it. Now, as far as actually doing anything with the session, I'm going to do all of that in an extension on our app delegate here. And we'll make this a WC session delegate. Now, there are a couple of required methods that we're going to need to make sure that we implement here in order to actually do anything with the session. And the first one's going to be session did deactivate, and you can see that auto-completed for us there. Now, I'm not going to do anything with this right this second, but the idea here is this session did deactivate will get called if the session ends for any reason whatsoever. And that can be a myriad of different things. It could be that the Bluetooth connection was broken somehow. Maybe you got too far away between the two devices, or for whatever reason, there was just an error and the connection failed. Next up is session did become inactive. Now you can see here, this tells us too that this is called when the session prepares to stop communicating with the Apple Watch. So this is essentially telling you, hey, we're going to go ahead and pause the connection because we're not actually sending any data. So it's just wasting battery by actually having it constantly on. And again, we're not going to do anything with this at the moment, but this is required. So let's go ahead and make sure that we implement it so that, we actually have everything that we need. Next up is going to be the session's activation did complete. There we go. So you can see this is activation did complete with, and it gives us an activation state as well as an error pointer. Now, this is going to get called whenever the activate method is called, like we did up here. Now, this is also going to tell us if anything went wrong, if something happened that we need to know about. Again, for now, though, I'm not going to worry about this because, again, we're just going to do something fairly basic here. But this is also a great opportunity to go ahead and print out that error's localized description if you end up running into any issues establishing your connection and passing data. So the last method that I'm going to focus on here is the sessions did receive message. Now, there's a couple of different versions of this that you can see here. There's just did receive message, there's did receive message data, and then there's also alternate versions of both of those that include a reply handler. What I'm going to use for this is did receive message without the data, but the version that uses the reply handler. And that way we can send data back based on whatever that message happens to be. Now, because this method can get called at just about any time, I'm going to go ahead and use a dispatch queue here. And we'll make sure that it's asynchronous in order to do anything else that we need to do within received message. Now, the primary reason for this is because WC session can actually wake up the application in the background. So even if the user's actually doing something else with their phone, this app can actually be turned on in the background and data pulled from it over to the watch. Now, this is a great advantage for us because it means that the user doesn't have to constantly have both applications open in order to actually transfer data between our two sides. But at the same time, we need to make sure that we're not blocking any main threads, especially the UI thread, if they do happen to be doing something else on their phone, because that just causes a poor user experience for everybody. Now in here, we're actually going to go ahead and double check what that message is first before we do anything. So we'll say if message happens to be get balance, and we'll go ahead and consider that this would be sent as a Boolean. And if that happens to not be nil. Now, in this case, essentially all I'm doing is I'm going to end up sending the message get balance with a Boolean of yes from our watch side. But because we haven't written that yet, we kind of have to take this a little bit on faith as far as what we're going to do on the other side of this. Now, this is also a good opportunity to point out, this is where we should be doing things like usingplists or any other sort of helper file to establish things like keys like get balance and messages, where you don't have to worry about mistyping it. So this should be a file that gets included across both of these two targets. So if this does happen to be get balance, which is what we were looking for, let's go ahead and package up a object in order to send across. Now, in order to actually use the NS-keyed archiver to actually package things as data and send them across, we need to establish which class we're actually going to be using with the keyed archiver first. So in order to do that, we'll tell the NS-keyed archiver to set its class name. And in this case, this is going to be our balance class. And yes, this is case sensitive, so make sure that if you do have lowercase b or you use a different name, make sure that that matches exactly. And then we need to say for balance.self. Now all that's doing is telling the NS-keyed archiver, this is the class name, and this is the class object that you should be using in order to encode and decode anything that happens for the remainder of this method. So now let's go ahead and actually create a balance object. And we're just going to fill this with some dummy data. So we'll say balance, and we'll use our initializer that we created. And for the date, let's just say 1/1/2017. And for the balance, let's go ahead and do something that, obviously we would recognize as correct data. Something that we didn't use for the dummy data, at least. So now that we've established with NS-keyed archiver what class that we're going to use, and we've actually created the class object, let's go ahead and convert that to NSData. So we'll say let data equals NS-keyed archiver archived data with root object. And the object that we're going to pass in is obviously our balance object that we just created. So now that we have the data object, let's go ahead and pass it back to our watch side. And we can do that using the reply handler that was given to us in this method. So we can simply say reply handler. And you can see that the reply handler takes in a dictionary, so a key value pair system here again. Now there is no other way around that. Even if you wanted to send an entire array of data across, it would still have to be a key value pair system. So you'd have to have a key that said, my array or whatever, and then the actual object could be the array itself. That's fine, but it still has to be contained within a dictionary at the top level. So for this, I'll say that this is our new balance. And the object we're going to use is that data object that we just created. So now when the watch side goes ahead and asks us for the current balance, we can go ahead and pass this back just like we do here. Now, obviously in a real system, you'd be using data that you pull from, either a server or that you had saved within your system already. But for these purposes, obviously, we're just doing a demonstration. So I just want to make sure that you understand how we're actually packaging up the data and sending it across to the watch. So now that we've done all that, let's go ahead and actually work with the watch side a little bit. So in order to do that, I'm going to first start over here in our actual WatchKit app. Now you can see here in the storyboard, it actually gives us a watch style system so that we can actually lay out everything we need to, and it will look just like it should on the watch. Now with the watch, you're actually going to have a slightly different setup than you're typically used to with iOS, and that's because the watch actually has layout gravity. Now the primary reason for this is because with watch, they don't necessarily want to have to worry about different size classes and all this other stuff. You're so constrained with space as it is that it just makes more sense to have things basically auto lay out themselves. And this way too, you don't have to worry about the two different sizes of Apple Watch. So with the 38mm and the 42mm sizes, you actually never have to worry about creating separate layouts or doing any constraints or anything. With this system, all you ever have to do is drop things in, and it'll automatically expand them for the 42 size. So for what we're going to do here, I'm just going to add a couple of different pieces that we're going to need. So we'll go ahead and add a label here at the top. And this is actually going to be our date label, but we'll go ahead and set that up a little bit later inside the actual watch extension. Now, just like with everything else in iOS, you can go ahead and change the layouts a little bit. You can expand things as you need to. And we can change any of the properties that we need to as well. Now, the thing that's slightly different is going to be this alignment system. Now, if I change the horizontal to center, it doesn't change anything, right? But that's because I've expanded it to the entire width of this screen already. But with the vertical, if I say I wanted this label to be centered within the layout gravity, it'll go ahead and do that. And now anything else that I add to the system afterwards will actually go ahead and change based on that layout system. So let's say I wanted to add another label. And you can see that that starts out at the top left because that's the default alignment here. But if, say, I change that to right and bottom, you can see that the layout gravity automatically keeps things where they're supposed to be. Now, if I were to then, say, change this from bottom to center so that they're both in the center, now you can actually see that they will even themselves out and give each other basically as much space as possible in order to create a nice uniform layout for everything. Now for this, I'm going to go ahead and change this back to left and top. So we definitely want one up here, and that's going to be our date label. I'm just going to go ahead and increase the size of that a little bit. And then for this one, this is actually going to be where our balance is going to go. So I'll leave that as center center, but then I'll go ahead and change the actual text alignment here to be centered as well. Now, just like with iOS, we've got a lot of the same UI stuff that we still have, but they're going to be slightly different. So instead of UI button or UI label, we have WK interface label and WK interface button. Now, there's really not a whole lot of difference as far as what you can do with these different systems, but it's really more of a case of having to establish limitations on what should be done with these things. So again, on the watch, we're going to be much more limited as far as processor power and battery life. So you want to try and keep interactions and things like that to a bare minimum. Now for this button, I'm going to go ahead and put that on the bottom. And we're going to change this button title to Get Balance. I'm going to add one more thing here, and that's going to be a separator. Now this is actually something that doesn't exist on iOS. This is a watch-only thing. And this is essentially just a line. I mean, that's all it really is a way of basically, visually breaking up what's actually on the screen for the user. Now that's all we're going to do here in the UI. We don't really need to do a whole lot else because, again, we're just testing being able to pass data back and forth and then displaying that on our watch. So we're going to go ahead then and move over to our WatchKit extension. And there we're going to set up the other side of that connection. And then we'll hook everything up to the UI here after that. So let's go ahead and move over to our WatchKit extension. And we're going to do all of our work here in the interface controller. Now, interface controllers, or in this case, a WK interface controller class, are really just the same thing as a UI view controller, but just the watch equivalent. Now, there's some slight variances on how these work. The main one being that WK interface controllers actually have built in all the stuff for doing table views. So you don't actually have to worry about making it a table view delegate or data source or any of that. It's typically assumed that a WK interface controller at any time should be able to handle a table, just because you have such limited screen real estate on the Apple Watch that having scrolling lists of content is really, really common. Now in here, I'm going to start off by importing the watch connectivity framework again. So with that imported, let's go ahead and also turn this WK interface controller into a WC session delegate. Now, before we do anything else, we need to make sure that we actually add one of the required methods, but this required method was only made required after a certain watchOS version. So we're going to go ahead and make sure that we're at least that version or above in order to ensure that we don't actually end up crashing if we were to build this for a lower version of the watchOS. So we'll go ahead and use the @available keyword, and we'll say watchOS 2.2 and then asterisk. Now all that's saying is if we are on watchOS 2.2 or above, which is the other side of this, then we'll go ahead and do what happens next here. And that is a public function called session activation did complete with. And you can see that this gives us an activation state and an error pointer. Now, this is also on the app delegate on our iOS side, but for this one, we need to establish that this is actually something that's only available on watchOS 2.2 and up. Now, typically, this isn't going to be something you need to worry too much about just because we're already on watchOS 3, and it's highly likely that in the near future, we're going to be on watchOS 4 or above. So having to worry about conforming to something that's lower than 2.2 is not that big of a deal. But again, it's good to make sure that we actually have our bases covered just in case we were to have to target watches at a lower OS version. So now that we have that, let's go ahead and add some outlets for all the stuff that we added to the storyboard earlier. So we'll create an IB outlet for both the balance text, and this is going to be a WK interface label. And we'll do the same again for our date text. Now you can see that we have our WK interface labels here, and that's typical of basically everything on the watch side. So where there might be a UI counterpart on the iOS side, so UI label, UI image view, etc. On the watch side, we have WK interface and then whatever it is you're looking for. So if you ever get stuck looking for exactly what type of object you're trying to use or whatever, you can make sure that you just type WK interface, and that'll generally get you where you need to go as far as any UI elements. Now, it is important to note too, UI elements on the watch side can't actually be created and added in code. Anything that you want on the UI has to be done in the storyboard, and then you can hook up outlets to it through your code. So I couldn't create a WK interface label object here and add it to the storyboard manually or add it to the view manually. Okay, so now that we have our label outlets, let's also go ahead and add our session object. So I'll say file private let session, and this is going to be a WC session object. Now I'm going to initialize this a little bit differently than I did on the iOS side. And there's no reason to do it one way or the other necessarily. This is primarily just for me to show you all the different ways that it's possible to accomplish the same thing using wildly different code. So whereas on the iOS side, we used the did set in order to actually establish that the WC session was available and initialize it, here I'm going to use what's called a ternary operator, or the $:: operator. And what this does is, on one side, we're going to say WC session is supported. So on this far side, the left, we need to make sure that we're giving it a Boolean value. So this always has to resolve to a Boolean. $: WC session default : nil. Now, what this is doing is everything to the left of this question mark has to resolve as a Boolean. So again, this is supported. It's just giving us back a yes or a no. But what this setup does is take it so that this Boolean, whatever it is, will actually establish whatever gets set here. So if this resolves to yes, if we get yes back from is supported, then we'll set this session object to WC session default. If it resolves to no or false, it'll get set to nil. So really what this is basically a one-line version of an if-else statement, but just using a Boolean and creating it in a little bit different way. So again, this isn't something that you have to do, but I just like showing you slightly different ways of accomplishing things, especially since these sorts of things are what end up on entrance tests for companies and what lead developers like to throw as curveballs at potential new employees. So now that we have that, let's go ahead and override the default initializer. And because we're overriding it, we need to make sure that we call super so that we don't lose any of the functionality from the initializer that was already there. And then we'll go ahead and set the session delegate. It's going to be ourself. And we'll call activate on the session. So now what we're going to do is set up an IB action for that button that we put on our storyboard so that we can actually send our message across to the iOS side and receive the data from it and set up our labels appropriately. So this will be an IB action function, and we'll just call it get balance. So here in get balance, let's go ahead and create a dictionary that we're going to send across in order to actually tell the iOS side that we need this data. This is also where we're going to have our reply handler so that when the iOS side sends it back, we'll go ahead and handle that receipt of data here. So let's create a dictionary called myValues. And this is going to be string any. And we're going to set this to get balance and true. Now, if you'll remember, back in the iOS side, what we were expecting here when we get a message from the watch is the message get balance. Now, again, this is case sensitive, so make sure if you're using capitals, you're using them in the same place. Make sure you don't misspell anything. So now with this created, let's go ahead and send it over to our iOS side. So we'll say if let session equals, and we'll establish if session is actually initialized, so it has data in it. And we'll also double check if session is reachable. And if both of those are true, now we'll go ahead and send our message across. So we'll use session, send message. And the message we want to send is myValues. Now for the reply handler, let's just go ahead and make a block here in order to actually handle that data when it comes back. And we'll do that with reply data in. And just so that the compiler stops yelling at us for a second, let's make sure that we handle this error handler as well. And I'm just going to set this to nil. Now, if you end up having problems with the functionality for your project, or if you end up having problems doing the code exercise, make sure that you don't set that error handler to nil, actually allow it to pass you back the error pointer and print out the localized description to help you better understand what's going on. Now here in the response, let's go ahead and print out that reply data just so we can actually see that, something has happened. Now, when it comes to testing this, on the simulators, it can sometimes take a little bit of time in order for this response to happen. Now, this is typically with lower versions of Xcode, the early versions of Xcode 8 and stuff as well. It seems like in the most recent update, they've actually changed this to where it actually happens rather quickly now. But it's entirely possible that you may end up still having a little bit of a wait here. So don't get discouraged and don't worry about it if, something doesn't happen right away. Sometimes that change can actually take a little bit of time. So let's go ahead and actually handle that data. So let's go ahead and establish another dispatch queue. Because again, we're never sure exactly when this data is going to come back, so we don't want to block anything if at all possible to avoid. So in here, we'll say if let data, and we'll set that equal to our reply data. And again, because our reply data is always going to be a dictionary, we know we can just go ahead and access whatever data we're looking for using the key that we need. And in this case, that key is going to be New Balance. So again, don't forget over here in the iOS side, when we packaged this up and sent it across, we used that same key, New Balance. So that's what we're looking for over here in the response. And we'll cast that as data. Because again, we need to make sure that we're actually pulling things out as the appropriate types. Now, if that works, let's go ahead and decode the data. So just like before, we have to set the actual class that the archiver is going to use. But in this case, we actually want the NSKeyed unarchiver. So again, when you're packaging stuff up in order to send it across or to save it, use the keyed archiver. When you're unpackaging it on the other side or unpackaging it after loading it, you're going to use the unarchiver. And we're going to call set class, just like we did before. And we'll tell it balance.self. And for class name, balance. And again, we'll do a little bit of optional binding because we don't want to, end up in a place where this is going to crash or have any problems where it's just difficult to track down. By using all this optional binding, it just makes it easier for us to know exactly where something failed. So we'll say if let balance object, and we'll use the NSKeyed unarchiver to unarchive object. And it wants a data object, so obviously let's go ahead and pass it the data object we just pulled out of that response. And let's make sure that we cast it appropriately as our custom balance class. So if we've gotten all the way down here and everything worked appropriately, we were able to receive the data, we were able to unpackage it and unarchive it. Now let's go ahead and set our labels appropriately. And this is where you make sure that you actually spell things correctly. So we'll go ahead and set our date text. And you can see that they have a set text method built in for us. And for that, we'll use the balance objects date. And just make sure that we do the same thing for our balance text. And that should be all that we need there. Now let's make sure that we go ahead and clear up any issues here. We just need to make sure we close off our dispatch queue there. So now that we've established this and we finished up the class, let's go ahead and hook up everything in the storyboard before we go ahead and run this. So I'll hook up my balance text label and my date label. And I'll also hook up the action for my get balance button. Now you'll note when I hooked that up that it didn't bring up the typical iOS list of button interactions. And that's just because on Apple Watch, there's just the one. It's just touch up and side, which is what we typically use on iOS anyway. But it just makes it so that you're not worrying about trying to do intricate little interactions on a screen size that small. So now with all of that hooked up, let's go ahead and build and run our application. Now before we run it, go ahead and make sure that you're in the actual watch target as opposed to the iOS target here. That just means that we're actually going to run on the watch and we'll test the watch side, which is what we want to make sure we're actually getting the data from the iOS side and displaying it on our labels here. Now the other thing you'll note too is when we switch over to the watch target, you'll see that the simulators have both a watch and a iOS device. And that's because both of these simulators will run at the same time and actually exchange data between the two simulators, which is really nice. We don't have to worry about having actual hardware to test that stuff. So let's go ahead and run these. Now you'll note that the Apple Watch side popped up here, but the iOS side didn't. The iOS sim is still running, but it doesn't actually open the application. And that's because, again, when we establish that connection, we're not actually turning on the app. All we're doing is opening it in the background in order to pull data from it. So now if we go over here and call get balance, you'll see that we've gone ahead and pulled all of the data. We have the correct date and the correct balance. Now, when I printed out the actual data that got sent across, you'll see all these values down here. Now that's just because we packaged this up as an actual data object and not our custom class, because that's the only way we can send it across. But it's still a good place to have that print just so that you know that you actually got real data across and that nothing got messed up. So that's going to do it for this one. If you have any questions or comments, please direct those to your instructor. And as always, the version of this project with a lot of extra commenting and all of this established is going to be provided for you in the research assignment so that you can use that as a reference as well.